It's 1940. Britain is under siege. Nazi bombers darken the skies, and only a handful of young pilots stood in their way. Armed with a secret weapon and engine that was never supposed to work. An engine that nearly killed its test pilots and almost bankrupted the company that built it. Yet this engine, the Rolls-Royce Merlin, did more than power aircraft. It powered victory itself. Today we uncover the shocking truth behind the most important engine ever built, the story of how thunder became triumph. It is 1933, and while the world sleeps, something extraordinary is taking shape inside a dimly lit factory in Derby, England. At a time when war still seemed unthinkable and the scars of the Great War remained painfully fresh, a small team of Rolls-Royce engineers worked in silence on a machine that would one day make their grandfathers proud and their enemies tremble. The Merlin was not born from government demands or military contracts, but from corporate ambition and one man's relentless obsession with perfection. Henry Royce, the legendary co-founder who had died just 3 years earlier, seemed to haunt every blueprint, every calculation, and every sleepless night spent chasing engineering excellence. The project began under a deliberately secretive name, PV-12. Private Venture 12, while others focused on mass production, Rolls-Royce pursued absolute performance, unknowingly forging the blade that would one day cut through tyranny. But perfection demanded a terrible price, paid in blood, sweat, and shattered dreams. At the heart of this machine was engineering brilliance that defied convention. A liquid-cooled V1 capable of unleashing extraordinary power from 27 liters of displacement. Yet the true genius lay not in its size, but in the unseen details: 12 cylinders aligned in perfect 60-degree harmony, piston strokes calculated with precision, valve timing perfected, cooling passages sculpted to extract every ounce of power, and a supercharger where innovation bordered on madness, turning raw engineering into legend. A centrifugal supercharger force-fed the engine with pressurized air, allowing it to maintain devastating power even as pilots climbed into the thinning cold of high altitude. At sea level, the Merlin produced 1,030 horsepower, and even at 16,000 feet, where air should have robbed it of strength, it continued to deliver the power our pilots needed most. Yet beneath its polished aluminum skin lurked a fatal secret. A flaw so fundamental that it nearly ended the Merlin before it ever had the chance to roar. The earliest versions did not merely fail, they died violently. History rarely admits this, but the first Merlin engines were killers not of enemies, but of the brave test pilots who trusted their lives to this unstable machine. Catastrophic failures turned aircraft into falling coffins as cooling systems boiled glycol until lines burst, engines seized without warning, and temperature gauges spiked moments before disaster. Connecting rods snapped under stress, but the most terrifying failures came from the bearings. Imagine flying at 300 miles per hour, 20,000 feet above hostile territory. When the engine suddenly locks, solid, no warning, no gradual loss of power, only instant, deadly silence. It was not just mechanical failure. It was a death sentence written in oil and metal. Driven by desperation, engineers worked without rest, redesigning bearings, reformulating lubricants, and endlessly testing cooling systems until their hands bled and their eyes burned. Because they understood something the world did not yet grasp. Time was running out. By 1938, as Europe raced toward war, Merlin was still killing pilots, and the pressure became unbearable. While Hitler's war machine gathered strength across the Channel, British engineers fought their own battle against annihilation as government officials demanded answers. Test pilots demanded reliability, and the RAF demanded an engine capable of winning an inevitable air war. For a time, the Merlin seemed destined to remain a beautiful, powerful, and deadly failure until the breakthrough came. Advances in metallurgy solved the bearing crises, redesigned cooling systems tamed the overheating, and new manufacturing techniques erased the weaknesses that had haunted the engine from the beginning. Finally transforming the Merlin from a killer into a legend, it was not just engineering. It was engineering under fire, with the fate of nations hanging in the balance. By early 1939, the Merlin was finally ready, not perfect, but ready, and production surged, just as the first shots of World War II echoed across Poland. Britain had forged its sword just in time to wield it. In August 1940, the skies above Britain became the stage for the most decisive air battle in history. This was no ordinary campaign. It was the moment when the survival of democracy itself hung by a thread. Hitler's Luftwaffe had crushed Poland, swept through France, and now turned toward the green fields of England. Rising to meet them were the Supermarine Spitfire, with its elegant elliptical wings and the rugged Hawker Hurricane, the workhorse that would absorb the fury of the storm, both driven by the thunderous heart of the Merlin. From rooftops and bomb shelters, civilians watched as these machines climbed into contested skies, carrying the nation's hopes, prayers, and future. On September 15th, now remembered as Battle of Britain Day, the Luftwaffe unleashed everything it had on London. Wave after wave of bombers guarded by Germany's finest fighters. What they had not anticipated was the sound that rose to meet them, the deep, defiant roar of 1,030 horses unleashed in defense of home. By sunset, the tide had turned. The Merlin had not merely won a battle. It had helped save Western civilization. Yet the Spitfire was only the beginning of the Merlin's hidden war. While the world focused on dogfights over Britain, the engine quietly powered a fleet of revolutionary aircraft whose very existence was once top secret. The de Havilland Mosquito, the wooden wonder, paired Merlin power with radical construction. Built from wood and fabric, yet fast enough to outrun fighters while carrying a bomber's payload. Its twin Merlins pushing it beyond 400 miles per hour. Then came the Avro Lancaster, mounting for Merlins on a single airframe to create a heavy bomber capable of carrying 22,000 pounds of destruction deep into the heart of Nazi Germany. Perhaps most remarkable of all was the P-51 Mustang. Originally a capable but limited fighter, it was transformed when British engineers fitted it with a Merlin V1650, turning it into an escort that could carry bombers all the way to Berlin and back. The Merlin's success was now so overwhelming that demand was about to exceed anything Britain alone could supply. Britain now faced an impossible choice: protect its greatest secret or watch the war slip away. By 1940, the mathematics of survival were unforgiving. The RAF needed thousands of Merlin engines, while Rolls-Royce could produce only hundreds. German U-boats were strangling supply lines. British factories were bombed night after night, and time was running out. Desperation demanded a gamble as bold as it was dangerous handing. America's Packard Motor Car Company complete access to the Merlin's most closely guarded secrets. Every blueprint, every metallurgical formula, every hard-won engineering lesson was shared. It was industrial espionage in reverse. On paper, the deal was simple. Packard would mass-produce the Merlin under license, using American industrial power to solve Britain's production crisis. In reality, it nearly collapsed under the weight of a cultural collision. British precision met American mass production, and sparks flew. When British engineers arrived in Detroit, they discovered a fundamental problem. Their designs were measured in fractions of inches. While American tooling worked in thousands, every tolerance had to be converted, every specification recalculated. While London burned under German bombs, and the fate of the free world hung on whether to engineering cultures could learn to speak the same language. What followed was a manufacturing nightmare worthy of a thriller. The first Packard-built Merlins were failures, pistons seized, bearings disintegrated under load, and cooling systems burst at the worst possible moments. American assembly line workers, masters of automobile production, struggled with the unforgiving precision demanded by aircraft engines, while British craftsmen, shaped by centuries of tradition, valued individual perfection over sheer quantity. Both sides clashed, and both were partly right. Yet instead of surrendering, they adapted. British engineers shared secrets they had guarded for decades, teaching the subtleties of precision machining and quality control. American manufacturers introduced production techniques Britain had never imagined. Slowly and painfully, the Packard Merlin emerged, stronger, more consistent, and in some ways superior to the original. Improved alloys, tighter quality control, and refined mass production methods transformed it into a masterpiece of industrial cooperation. By the war's end, Packard had built more than 55,000 Merlins, far exceeding Rolls-Royce's output, powering the P-51 Mustangs that swept German fighters from the skies and made final victory possible. When the guns finally fell silent, the Merlin faced a new enemy: obsolescence. Jets were proclaimed the future, propeller-driven aircraft dismissed as relics, and the Merlin seemed destined for the scrapyard of history. But this engine, which had already defied death so many times, had one final surprise left, because in peacetime, the Merlin revealed a hidden versatility that would carry its legacy far beyond the war. Britain faced an impossible decision in 1940: protect its greatest secret or lose the war. The RAF needed thousands of Merlin engines, but Rolls-Royce could produce only a fraction. While U-boats choked supply lines and German bombs fell nightly on British factories, the answer was a desperate gamble handing the Merlin's most guarded secrets to America's Packard Motor Car Company. Every blueprint, formula, and hard-earned lesson was shared, turning secrecy into survival. What followed was chaos. British precision clashed with American mass production. Measurements didn't match. Early engines failed, and the entire program teetered on collapse. But instead of breaking apart, both sides adapted. British engineers taught precision. American industry taught scale. The result was the Packard Merlin, stronger, more consistent, and produced in numbers Britain could never achieve alone. By war's end, over 55,000 had been built, powering the P-51 Mustang and helping secure victory. When peace came and jets took center stage, the Merlin seemed finished until civilian aviation revealed that the engine which had won the war still had one final chapter left to write.